Hello everyone, today's class about op-amp circuit types, inverting and non-inverting amplifiers. As you remember, in the previous we have seen about op-amp circuits. During op-amp circuits, we have the golden rules for op-amp circuit analysis. That means the non-inverting equal to V inverting. That means as the same potential, virtually grounded. The circuit between both inputs is called virtually short circuit. So, as you see in the previous, we analyzes the concept of virtually grounded or virtual concept. So, we can get V non-inverting the same as V inverting. That means as the same potential. So, let's see types of op-amp one by one. When you see inverting amplifier, signal and feedback resistors connected to inverting inputs. When our V source or V in to the V inverting and V out becomes to the V inverting, this circuit becomes inverting amplifier. Input is applied to the inverting terminal, reverses the polarity 180-degree phase shift of input signal while amplifying it. So during inverting amplifier, V non-inverting the same with V inverting connected to grounded. So let's see analyze inverting amplifier. As you see, is our V in to the inverting terminal and V out back to the inverting terminal. During this time, what about our IS and IF? So according to the golden rule of op-amp circuit analysis, I source equal to minus of IF. So IS means VI minus of V inverting. IS means VI minus of V inverting over RS becomes minus IF means V out minus of V inverting. V out minus of V inverting over RF feedback resistor. So that means, as you remember, according to the golden rule, V non-inverting is grounded. So that means V non-inverting the same with V inverting. When you say V non-inverting is grounded, that means V inverting and non-inverting becomes 0. So V in, that V inverting replaced with V inverting, that becomes 0 minus of 0 over RS V out. Please don't forget that the signal minus, it is a minus of V out, V inverting again replaced with non-inverting, that becomes 0 over RF. This means VI over RS equal to V out over RF. So V out means, when you crisscross this one, V out means minus of RF over RS multiplied by V in. This is our V out. When you crisscross analyze this one, V out becomes minus RF over RS multiplied with VF. So what is the gain of our this op-amp? We need the gain. Gain means the ratio or multiplied of input signal and output signal. So the gain means the ratio of V out over V in. So this becomes minus RF over Rs. This is our gain for inverting signal. So what does mean negative feedback? That negative can control our outputs by minus Rf over Rs, that is inverting op-amps. So our gain for inverting amplifier or inverting op-amp minus Rf over Rs. This is our gain. So when you see in our PowerPoint, V out becomes minus of Rf over Rs multiplied by Vs. That means V in. So our gain for inverting amplifier or op-amp V out over Vs. That is minus of Rf over Rs. This is our gain. Yeah, you see how to say analyzes the gain of the op-amp for inverting. Let's see an example. Find the closed loop gain of the following inverting amplifier circuit. Yeah, this is inverting amplifier. Our Vin is in the inverting terminal. So our feedback resistor 100 kilo ohm and our Rin 10 kilo ohm. So determine the gain of this op-amp. You know, remember the gain of the op-amp for inverting amplifier is minus Rf over Rs. That means feedback resistor over input resistor, that is Rin. So we can substitute the value of resistor in the circuit as shown. Rin equal 10 kilo ohm and Rf equal to 100 kilo ohm, and the gain of the circuit is calculated as minus Rf over Rin. This becomes 100 over 10, that become minus 10. The gain of this inverting op-amp is minus 10. So negative feedback means we can control. When it changes the value, our gain becomes changed. So that is controllable, predictable type of amplifier during negative feedback. So gain V out over Vin, that become minus Rf over Rin. Let's see another example. If the circuit below has R1 equal to 100 kilo ohm and feedback resistor is equal to 500 kilo ohm, what about output voltage result for an input of V1 equal to 2 volt? When our input voltage is 2 volts and R1 is 100 kilo ohm and feedback resistor is 500 kilo ohm, determine V out. So V out becomes minus Rf over R1 multiplied by V in. So this means minus 500 over 100 multiplied by 2 volts, we can get minus 10 volts. So our inverting op-amp becomes amplified. Our input is 2 volt, but output is 10 volt, but inverted. That is a negative signal. Positive input, but in the output negative. That is inverting. What does mean that? Inverting amplifier, out of phase. So in 180 degrees shifted. So we get minus 10 volt when our 2 volt by controlling of this gain Rf over Rn. So where they apply inverting op-amp or inverting amplifier, that is trans resistance amplifier circuit. One useful application of inverting amplifier is that of a trans resistance amplifier circuit. A trans resistance amplifier, also known as a trans impedance amplifier, is basically a current to voltage converter, current in and voltage out. They can be used in low power application to convert a very small current generated by photodiode or photodetecting device etc. into usable output voltage which is proportional to the input current as shown in the figure. Look, our input through this photodiode, then in photodiode from light to electrical charge convert this photodiode. Then our input is current, then our output becomes a voltage. So that is current voltage converter, means one type of inverting amplifier. So the simple light activated circuit above convert a current generated by the photodiode into a voltage. The feedback resistor Rf sets the operating voltage point as the inverting input and controls the amount of output. The output voltage is given as V out becomes I source multiply with RF. Therefore, the out voltage is proportional to the amount of input current generated by the photodiode. So this is application of inverting op amp. Now the next, let's see non-inverting amplifier. How they analyze of this one, or what is the gain of non-inverting amplifier. So during non-inverting amplifier, feedback resistor still to inverting input, but no voltage source on inverting input. Note change of current flow. Input voltage to non-inverting input. So as you see in this circuit, our input voltage to the non-inverting. The inverting signals grounded, but still the output feedback is to the inverting. So let's see to determine the gain of this circuit. So as you see the circuit, our input is in the non-inverting. The inverting terminal becomes grounded. The feedback to the inverting terminal. Look in the left feature also. That is the same with this circuit. Look only to understand or to clarify the voltage divider of that for inverting terminal. The positive in the upper side, that is our V in it to the non-inverting. The inverting below that, the inverting terminal. So the feedback resistor to the inverter terminal. So to analyze or to determine the gain of this op amp for non-inverting, so first determine for this voltage divider, that is inverting terminal. So V divider for this one, V inverting becomes R1 over R1 plus RF multiplied by V out. This is a voltage divider during series circuit. So when you get this inverting by this equation, as you remember the rule of op amp circuit, V non-inverting equal to V inverting, because virtually grounded. Virtually ground, that becomes the same. So we get V inverting, so replace this V inverting to our V in. So V in becomes, this V in becomes R1 over R1 plus RF multiplied with V out. So V inverting replaced by V in. Because of what? Both are V non-inverting and V inverting are virtually grounded. So our V into the non-inverting terminal. So this non-inverting the same with non-inverting by the means of virtually grounded rule. Don't forget, please. So what does mean V out? When you simplify this one, V out becomes simply R1 plus RF over R1 multiplied again by V. This means R1 and R1 are the same. So 1 plus RF over R1 by V. This is our V out. So our main point is the gain of non-inverting amplifier. So gain means the ratio of V out over V in, or the multiple of input signal and output signal. So V out over V in is gain. So our gain is V out over V in. That means 1 plus RF over R1. This is the gain of non-inverting op-amp from this circuits. So according to the rule, V inverting the same with V non-inverting. So IS equal to IF. So IS minus V inverting minus 0 over RS equal to IF minus V out minus V inverting over RF. Since IN equal to 0 and V inverting the same with non-inverting, the same with V source, since no current flows through R, that according to the law. So V out becomes 1 plus RF over RS multiplied V inverting. So that V inverting is replaced with Vs because of virtually grounded both inputs. So V out becomes 1 plus RF over RS multiplied with V source. So the gain of non-inverting op-amp V out over V in or Vs equal 1 plus RF over RS. So by this equation we can amplify during non-inverting op-amp. So input is applied to non-inverting terminal. Output has same polarity phase as input signal, so they become amplified and in phase. So let's see example of non-inverting op-amp. Calculate the output voltage of a non-inverting amplifier below for value V1 equal 2 volt. So our V in is 2 volt, feedback resistor 500 kilo, and R1 becomes 100 kilo. So determine V out. So V out means 1 plus RF over R1 multiplied by V in. So this becomes 12 volt. Our output becomes 12 volt. So our input is 2 volt, that is positive, in the out becomes also positive because our op-amp is non-inverting amplifier. So we can, let's in this second example, design non-inverting amplifier with gain of 25. When our gain is 25, what about R1 or R2? So for the above gain, V out over V in, that is non-inverting, R1 plus R2 over R2, so gain becomes 25, then the gain minus R1 plus R2 over R2, that is 1 is equal to 25. When you crisscross this one or simplify this one, R1 plus R2 same with 25 of R2. So R1 minus, when you jump this one, R2 minus of 25 minus R2, R1 becomes 24 R2. So therefore, choose R2 1 kilo ohm and R1 becomes 24. So R1 means 24 multiplied of R2. That is simple equation or analyzing of the course. How they get the feedback resistor and the input resistors. The application of non-inverting op-amp includes the following. The non-inverting op-amp circuits are used where high input impedance is necessary. The circuits are used as voltage follower by giving the output to the inverting input as an inverter. They are used to isolate the particular cascade circuits. The non-inverting op-amp is applicable where the amplified output is necessary with in phase through the input. It is used to perform mathematical simulation like an adder. So one application of non-inverting is that is voltage follower or buffer. So our Vin is to the non-inverting, the feedback to the inverting, that is when the feedback resistor and Vin resistor input becomes infinitive and feedback resistor becomes 0. During this one, you know, the gain of non-inverting 1 plus Rf over, so 0 over 1 plus 1 is, that is 0. So our output becomes unity. So that means V out the same with V in. So this type of op-amp, we can call it voltage follower. So complementary form of the input voltage at its output as V out same with V in. This type of inverting amplifier configuration is generally called a unity gain inverter, or simply an inverting buffer. This unity gain amplifier is sometimes used as an input buffer, as it has very high input impedance and low output impedance. Voltage buffer amplifier used to transfer voltage from first circuit having high output impedance level to second circuit with low input impedance levels. So one application of non-inverting amplifier is buffer or voltage followers. So the next we will see about summing amplifier, that is other one type of op-amp circuits. So how they analyze this summing amplifier.